Hi, everyone. So, I wanted to look at some problems today that extend our learning from yesterday, where we were talking about our basic derivative shortcuts. Some of you weren't able to be here today because of CPR training, and so here's what we were talking about in class. Most of this is going to be done in class in the form of mini whiteboard practice, and so every time I put up a problem, you might actually want to pause the video and do the problem and then check out the answer. This stuff in particular, you might want to do that because you need to be practicing this, and I already know how to do it. Okay, so the directions say find y prime, and we'll also be finding y double prime in the first few problems. All right, so here's our first one. Y equals 5x squared. Please don't use the product rule here. I know some of you will be tempted to, but don't. You can, it will work, but most people who go down that path make mistakes and get the problem wrong. Instead, I would like you to think about this as a constant times a function. And you know then that the derivative of a constant times a function is that constant times the derivative of the function. So our constant here is 5. Our function is x squared. Y prime is going to be that constant times the derivative of x squared. The derivative of x squared, I'm going to use the power rule for, the polynomial power rule, which is when y equals x to the n, y prime equals n x to the n minus 1. So we have x squared. We're going to bring that 2 down in front, and we're going to have 2 minus 1 up here. So we're going to have 5 times 2x to the first, or y prime equals 10x. This is linear. We know that the derivative of a linear function is a constant, so y double prime is 10. Okay. What about something like y equals 5x squared minus 2x plus 3? Well, here we've got the derivative of a bunch of little functions tied together. Remember when we said yesterday, if y equals f of x plus g of x, then y prime is f prime of x plus g prime of x. And so really I just need to take the derivative of each of these pieces. So y prime, we know the derivative of 5x squared because we just did it, 10x, and the derivative of this linear function, negative 2x, will be minus 2. The derivative of a constant, of course, is 0. Think about this graphically. Here's y equals 3. The slope everywhere is 0, so the derivative of 3 is 0. Y double prime, that just means take the derivative of this. The derivative of 10x is 10, and the derivative of this constant is 0. Okay, how about this one? Number 3. Y equals pi to the third. And you might try and do something like y prime equals 3 pi to the 3 minus 1. And I would make a sad face and cry because pi is not x. This is not a variable. This is a number. This is a number raised to a number. If I pull out my calculator, I can ask what's pi to the third, and my calculator will give me a number. So what's the derivative of a constant? Well, the derivative of a constant is 0. Okay, this is different, of course, than y equals x to the pi. This I can use my power rule on and say y prime equals pi x to the pi minus 1. And what about y double prime? Well, y double prime is going to be take the derivative of this. I have a constant times x raised to a power. My derivative will be that constant times the derivative of this. Well, what's the derivative of this? I bring the power down in front, and I subtract 1 up here, x to the pi minus 2. And so I've got pi squared minus pi times x to the pi minus 2. There's my second derivative. We should, of course, from the microscope worksheet, remember that if y equals e to the x, then y prime is e to the x. E to the x is the derivative of e to the x. Okay, so how about you try these next couple on whiteboard? Think about pausing the video. Y equals 3x squared, 3x to the third minus 4x squared plus 5x minus 10. Okay, pause the video, give it a try. Welcome back. Y prime, we bring down the 3. This 3 times this 3 makes 9. X, subtract 1 up here, squared, minus a constant times a function raised to a power. I bring that power down. 2 times negative 4 is negative 8x. And I take the derivative of this linear function to be 5, and the derivative of a constant is 0. What about y double prime? Take a moment to try y double prime. Okay, welcome back. We're going to bring this 2 down. 9 times 2, 18. X, subtract 1, so we get the first power, minus the derivative of 8x is 8. Okay, B. How about y equals 3x to the minus 2 plus 7x to the minus 1 minus 3x. Okay, so what are we going to do here? Well, give it a try. It's not very dissimilar from the last problem we did. Don't forget to pause the video. Welcome back. Y prime is negative 6, because negative 2 times 3 is negative 6. X to the subtract 1. Minus 2 minus 1 is minus 3. Okay, now bring down the negative 1 times the positive 7, and we get negative 7x, and subtract 1 to the negative 2. And here, the derivative of negative 3x is negative 3. And check it out. We can even subtract 1 here and get x to the 0. What is x to the 0? 1. So 1 times negative 3 is negative 3. Now, note our original problem was this one. You might also see this problem I would feel like I need to use the quotient rule here. I don't want to use the quotient rule here. I think it's much easier, rather than use the quotient rule, to turn these fractions into negative exponents. This is going to be a much more streamlined and perhaps even successful way for us to deal with these problems. Okay, next. How about this one? C. Y equals ax to the third plus bx squared plus cx plus d, where a, b, c, and d are constants. We're taking the derivative of both sides, d dx, with respect to x. X is the variable we're taking the derivative with respect to. So dy dx here will be, bring down the 3, 3a x subtract 1, plus, bring down the 2, 2b x, because we're subtracting 1, it's just going to be x to the first, and the derivative of cx, which is linear, is c. What about the second derivative? with respect to x both times. Take the derivative twice of y with respect to x both times. Okay, so we'll bring down that 2. 2 times 3 is 6a x. We subtract 1, we get the first power. Plus, and the derivative of 2bx, well, this is just linear. It's some constant times x will be 2b. Okay? All right, now it's time for us to actually face the product rule and the quotient rule. So, E. Y equals 3x squared plus 2x minus 1 times x minus 4. Now, I understand you could FOIL this out, combine like terms, and then take the derivative, and that's certainly a way to do the problem. However, we definitely need to be practicing the product rule. You're going to have lots of functions like y equals sine x times ln of x, where you're not going to be able to do any FOILing here and take the derivative. So, let's take the derivative by using the product rule. Remember, if the functions are u times v, then the derivative of this product will be u times v prime plus v times u prime. So here's my u, here's my v. We want this one times the derivative of that plus this one times the derivative of that. Okay, so for us, y prime then will be 3x squared plus 2x minus 1 times the derivative of this. Well, the derivative of x is 1, and then we have our minus, and the derivative of a constant is 0. So really, this is just the derivative of 1x minus 4, which is just going to be 1. Now we have our plus this x minus 4 times the derivative of u. The derivative of 3x squared will be 6x, and the derivative of 2x will be 2. Okay, now, I will say that when we get to chapter 5, and we are in chapter 3 right now, when we get to chapter 5, you're going to be setting derivatives equal to 0 and solving. So I'm going to encourage you to take this a little further. 3x squared plus 2x minus 1 plus 6x squared minus 24x plus 2x minus 8, because we FOILed over here. Combine like terms, you get 9x squared minus 20x minus 9. I think I did that right. This, yes, this, and this, and this, and this. Good. So there's our y prime. Okay, so there's our product rule review. What about a quotient rule review? Y equals 3x over 2x plus 1. Okay, so remember with our quotient rule, where we have u over v, and these are both functions of x, when we take the derivative with respect to x, it's not the derivative of this divided by the derivative of this. Oh no, it's low d high minus high d low over low squared. And you really need that memorized. You need that like 7 times 6 equals 42 memorized. Okay, so y prime equals low, the function on the bottom, d high, the derivative of this, minus high, 3x, times d low, the derivative of this, which would be 2, all over low squared. So I've got 6x plus 3 minus 6x over 2x plus 1 squared. And that's going to simplify to 3 over 2x plus 1 squared. Okie doke. Great. Let's move on. Why don't you try this one? Y equals x squared plus 1 over 3x minus 2. Pause the video now and give it a try. Okay, welcome back. So y prime low d high minus high d low all over low squared. And so we get y prime equals 6x squared minus 4x minus 3x squared minus 3. Watch out for distributing mistakes. They happen to calculus students too. 3x minus 2 squared. So when I combine like terms, I have 3x squared minus 4x minus 3 over 3x minus 2 squared. Okie doke, there's our y prime or dy dx. All right, let's take a look at this one. Y equals x squared plus 3x minus 2 over x. And I'd like to consider doing this problem two different ways. One is, of course, with the quotient rule. Low d high minus high d low. The derivative of 1x is 1 over low squared. So I've got 2x squared plus 3x minus x squared minus 3x minus a minus is plus 2 all over x squared. And if we combine like terms, I get x squared, the 3x's cancel, plus 2 over x squared. There's my y prime. But I mentioned before I wanted to do this problem a second way as well. So the second way is I want to first rewrite this as a sum of terms. So that means splitting this into 1, 2, 3 fractions. So y could be x squared over x plus 3x over x minus 2 over x. Okay, and I can do a little simplifying here. So y equals x plus 3 minus, and remember what we did before about flipping this up and calling it 2x to the negative 1? I want to do that. So now y prime, the derivative of x is 1, the derivative of 3 is 0, and the derivative here, I bring down that negative 1 times the negative 2 that's already there. I get a positive 2, x, and subtract 1. Minus 1 is minus 2. Okay, now supposedly these are the same. Can you see how that is? Well, I could rewrite this as 1 plus 2 over x squared, and I can rewrite this one by splitting this up into x squared over x squared plus 2 over x squared to be 1 plus 2 over x squared. So both of these are correct. Both of these are ways to do this problem. You definitely need to know how to do the quotient rule, but sometimes we can avoid the quotient rule, and when I can avoid the quotient rule, I do. But at this point, when you're supposed to be learning the quotient rule, so that when you get to sine x over ln of x, and you can't split that up, and you have to use the quotient rule, you're comfortable with the quotient rule and can do it. Okay. Next, let's take a look at this issue. The AP exam loves table problems. And so I've got x, I've got g, I've got g prime, I've got f, I've got f prime. And let's say x equals 3, g of 3 is 1/2, g prime of 3 is negative 7, f of 3 is negative 2, and f prime of 4 is, f prime of 3 is 4. Okay? So now I'm going to give you a function, let's call it h of x, and h of x is 3x squared minus 5 times f of x. So I'm supposed to find h prime of x. Well, I know I need to take the derivative of this. Ooh, I need to find h prime of 3. So I'm going to start with h prime of x. and then I'll move on to evaluating the derivative at 3. Okay? So all of these are going to be h prime at 3. So the derivative of 3x squared, bring down the 2. 2 times 3 is 6x. Now over here we have the derivative of a constant times a function. Yes, you can use the product rule here, but please do not use the product rule here. Instead, you should recognize that it will be the constant times the derivative of the function. So I want to know h prime of 3. That means I want 6 times 3 minus 5 times f prime of 3. Well, f prime of 3 I get from the table, and that value is 4. And here we have 18. 18 minus 20, negative 2. So the next few problems that we do are all going to be using this table, okay? Number 2. h of x equals 2x plus 1 over f of x. And remember, we're looking for h prime of 3. But we're going to start by finding h prime of x. So how do we find h prime of x? Well, this is a quotient, so I need the quotient rule. Low d high minus high d low. The derivative of f is called f prime over low squared. And so if I want h prime of 3, that's going to be f of 3 times 2 minus 2 times 3 plus 1 times f prime of 3 all over f of 3 squared. Well, f of 3, I can tell from the table, is negative 2. This is 2 times 3 is 6, plus 1 is 7, times f prime of 3. F prime of 3 is 4. And all of that is over f of 3 squared. Well, f of 3 is negative 2, and negative 2 squared is 4. So I have negative 4 minus 28 is negative 32 over 4, or negative 8. H prime of 3 equals negative 8. All right. How about this one? 3. H of x equals f of x times g of x. Well, here we have a product rule. So h prime of x is going to be f of x times g prime of x plus g of x times f prime of x. You really need to know the product rule. If you haven't learned it already, you might want to stop this video and review product rule and quotient rule. Both of them are terribly, terribly essential. Okay, so we want h prime of 3, which means f of 3 times g prime of 3 plus g of 3 times f prime of 3. So what are we going to get? F of 3 is negative 2. G prime of 3, g prime of 3 is negative 7. Plus g of 3 is 1/2 times f prime of 3 is 4. And so we end up with 14 plus 2 is 16. Any questions about that? Okay. How about 4? Oh no, I erased the table. I just want to do 1 or 2 more. I'm going to redraw the table. Sorry. Okay, so we had x, we had f, we had f prime, we had g prime, and I know I'm writing them in a different order now, so please be careful and mindful of that. F prime was 4, and f was negative 2. Okay, so number 4, h of x equals f over g. So h prime of x is going to be low d high minus high d low over low squared. And since we want h prime of 3, that's going to be g of 3 times f prime of 3 minus f of 3 times g prime of 3, all over g of 3 squared. Okay, g of 3 is 1/2, f prime of 3 is 4, f of 3, this is a minus, is -2, g prime of 3 is -7, and all of this is over g of 3 squared. G of 3 is 1/2, and I have 1/2 squared. Please note 1/2 squared is not 1. It's 1/2 times 1/2, which is 1/4. So here I get 2. Here I have a minus times a minus times a minus, which is -14 over 1/4. So this is going to be -12 over 1/4. And when I do flip and multiply, I'm going to get h prime of 3 equals -48. Okie doke. Great. How about one last one? 5. h of x equals g of x over 2x plus 1. Pause the video now and give this one a try. Welcome back. So I see a quotient here, which means I want to use the quotient rule. H prime of x equals low d high minus high d low over low squared. So h prime of 3 then will be 2 times 3 is 6 plus 1 is 7 times g prime of 3. G prime of 3 is -7 minus g of 3 is 1/2 times this 2 all over 3 times 2 is 6 plus 1 is 7. 7 squared is 49. So we have -49 minus 1 over 49, which is -50 over 49. Okie doke. Nice. Okay. So let's talk a little bit more about second derivative and second derivative notation, and maybe even third derivative. Okay, so if f of x equals 6x to the 5th minus 4x squared, we know that we could represent taking the derivative with the imperative form. Take ye the derivative of both sides. And so we'd have df dx equals 30x to the 4th minus 8x. But what if we wanted the second derivative? Well, then we'd be taking the derivative of that derivative. So we'd be taking the derivative twice of f with respect to x both times. That's how I would write that notation. The derivative of this will be 120x to the 3rd, and the derivative here would be -8. And if I took the derivative, got to do it to one side, you got to do it to both. If I took the derivative yet again of both sides, I would have the derivative 3 times of f with respect to x all 3 times. And so I'd have 360x squared. The derivative of -8 is 0. Okie doke. So we could call this way. We could also call it f triple prime. And this would be f double prime, just like this would be f prime. Okay? Now, let's start looking at some application questions. This is a typical AP question. Show that y equals x to the third plus 3x plus 1 satisfies the equation y triple prime plus xy double prime minus 2y prime equals 0. Huh? Well, what this means is, before I do anything else, I need to find the first derivative, the second derivative, as well as the third derivative. Okay? So, here's y, x to the third plus 3x plus 1. Here's y prime, 3x squared plus 3. Here's y double prime, 6x. And here's y triple prime, 6. Now let's plug in y triple prime, y double prime, and y prime. Don't forget y double prime has to be multiplied by x, and y prime has to be multiplied by -2. Alright, so we're going to have 6 plus x times y double prime is 6x minus 2 times y prime. Well, here's y prime, 3x squared plus 3. And this should equal 0. Well, let's tidy things up. 6 plus 6x squared minus 6x squared. Don't forget to distribute this -2 to this 3 to get -6. And then when we combine like terms, we get 0 equals 0. This work is what we need to show that y satisfies this equation. Okay? All we need to do is show this work where we're adding y triple prime, x times y double prime minus 2 times y prime. And when we simplify everything over here, we get 0. Okay? Just a few more problems to look at with you today. Next, we see a typical AP question. Y equals x over x squared minus 9. And they ask us, where does y have horizontal tangents? Well, horizontal tangents have a slope of 0, and a synonym in our class for slope is dy dx. So I want to know when dy dx is equal to 0, which means I'm going to have to find dy dx, which means I'm going to have to take the derivative. So dy dx equals low d high minus high d low over low, don't forget to square it. And we want to know when this derivative is equal to 0. Well, I kind of want to tidy this up first. So dy dx equals x squared minus 9 minus 2x squared over x squared minus 9 squared. Dy dx equals negative x squared minus 9 over x squared minus 9 squared. Now, I just want to check before we go any further to make sure I did the quotient rule properly. Low d high minus high d low. Yeah, all over low squared. Okay, and so we have negative 2x squared, we have minus 9, we have plus 1x squared, we combine like terms, that's great. Why was I wondering about that? Well, when I get to this point of setting the derivative equal to 0, first thing I'm going to do is multiply both sides by the denominator. And what's going to happen when we do that? Well, over here, these are going to cancel, right? And so we're left with negative x squared minus 9. But over here, 0 times all this stuff is 0. So now let's add x squared to both sides. Uh-oh, do you see why? Now, uh-oh. Yeah, so when we get this, we say there are no horizontal tangents. Okay? Cool. Next, Jack was asking me about tangent line equations, so let's do one of those. if f of x equals 1 minus x over 1 plus x, I would like the tangent line at x equals 2. Well, Riley will tell you that in order to find the equation of a tangent line, you need a point and a slope. And to find the point, I need to plug that x value in. 1 minus 2 over 1 plus 2, and I get negative 1/3. So we have the ordered pair 2, negative 1/3. But we also need a slope, and for that, I need f prime at 2. So let's take the derivative of f of x using the quotient rule. Low, d high, watch out, the derivative of negative x is negative 1, not positive 1, minus high, d low, the derivative of positive 1x is positive 1, over 1 plus x squared. So f prime of x equals negative 1 minus x. Careful here, there's a lot going on. 1 times this stuff, well, it's just that stuff. So negative 1 minus a minus is plus x over 1 plus x squared. So if we combine like terms here, we get that f prime of x is negative 2 over 1 plus x squared. And we want f prime of 2. So that's negative 2 over 1 plus 2 squared, or negative 2, 3 squared is 9. So there's my slope. There's my ordered pair. Here's me writing the tangent line. Y minus a minus 1/3 equals negative 2/9 x minus 2. And you're welcome to tidy this up. You're even welcome to get it in y equals form. I'm not gonna. I'm leaving it alone. If, however, instead the question had read, what's the normal line? Remember, the normal is perpendicular to the tangent line, and so we'd have y minus a minus 1/3 equals perpendicular to 9/2. Change the sign, flip the fraction, x minus 2. Okay, now, got one last one. How about y equals x squared? And we're asked to find the x coordinate where the tangent line to y is parallel to the secant line on negative 1 to 2. Huh? Well, let's take a look at a picture. Here's y equals x squared. Here's negative 1, 1. And here's 2, 4. Here's the secant line. Now, I'm looking for a tangent line that's parallel to that. And so my guess is going to be somewhere around here, where these lines can be parallel. What do you remember about parallel lines? Their slopes are equal. Okay, so what's the slope of my secant line? The slope of the secant line will be 4 minus 1 over 2 minus minus 1. So that's 3 over 3, or 1. So I'm wondering when this function has a tangent line whose slope is 1. Well, at the point of tangency, not only does the tangent line have a slope of 1, but the function has a slope of 1. So let's find the derivative of this function. If y equals x squared, then y prime will be 2x. That's my slope pooping machine. I'm wondering when this slope pooping machine poops out a 1. 1 equals 2x. Divide by 2. X equals 1/2. The x-coordinate where the tangent line is parallel to the secant line would be here at x equal to 1/2. Okie doke. You might want to watch some of these again, and you should definitely be practicing your one-sided derivatives. I had these 3 problems in mind for a little extra practice, but I think we're going to call it quits today. Does f prime of 1 exist, and if so, what is it? And here we want to find a and b to make f differentiable at 1. Maybe we should do that one. And here, show that f prime of 0 exists, but that f double prime does not exist. Ooh. All right, let's do a couple of these. We'll skip the first one. We'll do numbers 2 and 3. You need practice with one-sided derivatives for your test, and these are good AP questions. Okay, 1. F of x is defined in this interesting piecewise manner. 3x squared, x less than or equal to 1, ax plus b for x greater than 1. And we're supposed to find a and b that make f differentiable at x equals 1. Okay, so what would Delaney say? Delaney would say that in order to be differentiable at x equal to 1, we need to show 2 things. The first thing we need to show is that f of 1 equals the limit as x approaches 1 of f of x. We need to show continuity. So let's plug a 1 into each of these pieces and see what we get. If we plug a 1 in here, 1 squared is 1, 1 times 3 is 3. And if we plug a 1 in here, 1 times a is a plus b. So in order for the function to be continuous, a plus b needs to equal 3. Here we have f of 1, and the limit will be a plus b needing to be equal to 3. Okay. What else would Delaney say we would need besides the function needs to be continuous? Well, she would also say the limit as x approaches 1 from the positive side of f prime should equal the limit as x approaches 1 from the negative side of f prime. We need the limit of the slopes to be the same. Now here we don't have to worry about using the limit definition of the derivative. We can use our shortcuts. The derivative here, build a little f prime of x function. The derivative here will be 6x for x values less than 1. And the derivative here, well, the derivative of a constant is 0, and the derivative of this linear thing is a for x greater than 1. Now, what must be true? The limits from both sides must be equal when I plug in a 1. So 1 times 6 is 6. And on the other side, there's nowhere to plug in a 1. I just have a. So I know that a equals 6, and 3 equals 6 plus b equals negative 3. So this problem wasn't about really using one-sided derivatives. It was much more about knowing our definition of differentiability and not getting freaked out by the presence of the a's and b's. Okay, last one. We're given f of x squared for x less than or equal to 0, x to the third for x greater than 0. And the directions say, show that f prime of 0 exists, but f double prime of 0 does not exist. Okay? So let's see. In order for f prime to exist, we need 2 things. We need continuity. So if we plug a 0 into both of these pieces, we get 0 equals 0. Good. And we need the limit of the slopes. So what would f prime of x be? Well, the derivative of x squared is 2x. And the derivative of x to the third is 3x squared. All right, so now what happens when we plug a 0 in? Well, I get 0 equals 3 times 0 squared, 0. So the function is continuous, and the limit as x approaches 0 from the positive side of f prime equals the limit as x approaches 0 from the negative side of f prime. So we know here that this function f of x, the derivative exists, f prime of 0 exists. But now what about f double prime of 0? That's not supposed to exist. Okay, well, let's check continuity first. Continuity of f prime in order to determine if f double prime exists. And if I plug a 0 in here and a 0 in here, I get 0 equals 0. So we've met the continuity test. What about differentiability? What would f double prime be? Well, f double prime is going to be 2 for x values less than 0 and 6x for x values greater than 0. Well, if I plug a 0 in here, I get 0. If I plug a 0, oh, there is no place to plug in a 0. I get 2. So we know that the limit as x approaches 0 from the negative side of f double prime does not equal the limit as x approaches 0 from the positive side of f double prime. Okie doke. Well, happy learning.